Welcome to the video on partial fractions. So with partial fractions, you're breaking apart fractions that are larger and have polynomials into smaller fractions. So for the IB test, they'll have a maximum of 2 linear terms in the denominator, like this, with a linear or constant term in the numerator. So here we just have it labeled n. So most of the times when they give it to you, it'll be in an expanded form, not in a factored form, and that's an additional step you'll have to complete. So you'll factor it out and then split it into a over your first linear term plus b over your second linear term. So for example, we have x plus 4 over x squared plus 5x plus 6. So the first thing you'd do is you'd split the denominator, which x squared plus 5x plus 6 can be factored to x plus 2 times x plus 3. And then you would write that x plus 4 over your factored form equals a over your first factor plus b over your second factor. Then you would multiply everything by the factored denominator. So we'd multiply this entire equation by x plus 2 times x plus 3. When you do that, you would end up with x plus 4 equals a times x plus 3 plus b times x plus 2. You'll then find the 0 for the first factor to solve for b, and then the 0 of the second factor to solve for a. So for this one, the 0 of our x plus 3 would be when x equals negative 3. So we'd have our x plus 4 equals a times x plus 3 plus b times x plus 2. And we'll plug in negative 3. So negative 3 plus 4 equals a times negative 3 plus 3 plus b times negative 3 plus 2. So then we get 1 equals a times 0 plus b times negative 1. A times 0 is 0, so that will go away. So 1 equals negative b, so negative 1 equals b. Now we'll find the 0 of our second factor, which is going to be when x equals negative 2. So we have negative 2 plus 4 equals a times negative 2 plus 3 plus b times negative 2 plus 2. So 2 equals a times 1 plus b times 0, which is 0, so it goes away. So 1a equals 2. A equals 2. So your partial fractions would be a, so 2 over x plus 2, plus b, so b is negative 1. So we'll do minus 1 over x plus 3. So that's this fraction here written in partial fractions. So here for this practice problem, we have write 2x minus 13 over x squared minus x minus 2 in partial fractions. So we'll start by factoring our denominator. So x squared minus x minus 2. So we need to figure out what multiplies to our c value, so what multiplies to negative 2, and adds to our b value. So it needs to add to negative 1. So a negative 2 times 1 equals negative 2, and negative 2 plus 1 equals negative 1. So we'll have x minus 2, x plus 1. So 2x minus 13 over x minus 2 times x plus 1 equals a over our first factor, so x minus 2, plus b over our second factor, x plus 1. We'll take this entire equation and multiply it by the factored denominator, x minus 2, x plus 1. So that gives us 2x minus 13 equals a times x plus 1 plus b times x minus 2. So to zero the first factor, we need x equals negative 1. So we'll plug that in. 2 times negative 1 minus 13 equals a times negative 1 plus 1 plus b times negative 1 minus 2. So that's negative 2 minus 13 equals a times 0 plus b times negative 3. A times 0 is 0, so that goes away. And we get negative 15 equals b times negative 3. So if we divide both sides by negative 3, we get that 5 is equal to b. So now we can find a by plugging in our 0 for here. So this would be 0 when x equals 2. So we have 2 times 2 minus 13 equals a times 2 plus 1 plus b times 2 minus 2. So 4 minus 13 equals a times 3 plus b times 0. b times 0 is 0, so it'll go away. 4 minus 13 is negative 9, so negative 9 equals a times 3. And if we divide both sides by 3, we get that a equals negative 3. So now we can plug in a and b over here. So we get 2x minus 13 over x minus 2, x plus 1 equals a, so negative 3 over x minus 2, plus b, 5 over x plus 1. Here we have another practice problem that says write 3 over 2x squared minus 3x minus 2 in partial fractions. So our first step is going to be factoring our 2x squared minus 3x minus 2. In this one, we have a number other than 1 in front of our x squared, so factoring is going to be a little bit more challenging. What I like to do is use the box method. So with the box method, you draw a 2 by 2 box. In the upper left corner, we put our a value, so our 2x squared. And in our bottom right corner, we'll put our c value, which is negative 2. So we need to find something that multiplies to our a value times our c value. So it's going to multiply to 2 times negative 2. So it needs to multiply to negative 4, and then it needs to add to our b value, so negative 3. So if we do negative 4 times 1, that'll give us negative 4, and negative 4 plus 1 will give us negative 3. So our numbers are going to be negative 4 and 1. So we'll put those in the other boxes with our x's. And then we need to pull our greatest common factor out of each row and column. So in this first row, our greatest common factor will be x. Our second row, the greatest common factor is negative 2. In our first column, we'll have 2x, and our second column is going to be 1. So our factored form will be 2x plus 1 times x minus 2. So we'll have 3 over 2x plus 1 times x minus 2 equals a over 2x plus 1 plus b over x minus 2. So we'll multiply the entire equation by our factored denominator, our 2x plus 1 times x minus 2. So that gives us 3 equals a times x minus 2 plus b times 2x plus 1. This factor here equals 0 when x equals 2. So we'll plug in 2 for x. So we get 3 equals a times 2 minus 2 plus b times 2 plus 1. So that's 3 equals a times 0 plus b times 2 is 4 plus 1 is 5. A times 0 is going to be 0, so that'll go away. So we get 3 equals 5b. And when we divide both sides by 5, we get that b equals 3/5. So we'll do the same thing, except we want the second factor to equal 0 now. So 2x plus 1 equals 0 when x is negative 1/2. So you could find that by subtracting your 1 and then dividing it by 2. So we'll plug in negative 1/2 for x. So we get 3 equals a times negative 1/2 minus 2 plus b times 2 times negative 1/2 plus 1. So we have 3 equals a times negative 1/2 minus 2. If we create a common denominator, this will be negative 4 over 2. So we get negative 5 over 2 plus b times 2 times negative 1/2 is negative 1 plus 1 is 0. So b times 0, that'll be 0, so it'll go away. So we have 3 equals a times negative 5/2. So we'll multiply both sides by negative 2 over 5. Because then this will turn into just a on this side. So we get negative 6 over 5 equals a. So we can go ahead and plug those back in. So we have 3 over 2x plus 1 times x minus 2 equals a, which is negative 6 over 5 over 2x plus 1, plus b, which is 3/5 over x minus 2. And then we'll multiply both fractions by 5 over 5 so that we can get rid of the fractions in our numerators. So we'll write our final answer down here. We'll have 3 over 2x plus 1 times x minus 2 equals negative 6 over 5 times 2x plus 1 plus 3 over 5 times x minus 2. So here's our final answer. So these partial fractions will be useful in some of the later calculations we'll do with calculus and things like that. In summary, when solving for partial fractions, you'll be given a fraction with a quadratic in the denominator and a linear or constant in the numerator. You'll first split the denominator into its factored form and then write two separate fractions with a over the first factor plus b over the second factor. Then you'll multiply everything by the factored denominator, which will then give you n equals a times cx plus d plus b times ax plus b. You'll find the 0 for the first factor, which would be negative d over c, and use that to solve for b. And then you'll find the 0 of the second factor, which would be x equals negative b over a, and use that to solve for your a value. And then you'll plug those in to have your final partial fractions. That's all for this video, and thank you for watching.